captured the object changing its trajectory in an unnatural manner, meaning it must be some sort of extraterrestrial light.
When the James Webb Space Telescope turned its gaze toward the deepest reaches of space, it didn't just capture light from distant galaxies, it expanded the human sense of scale itself. For decades, astronomers had worked with instruments that gave tantalizing glimpses of what lay beyond our own galaxy. But the Webb telescope pulled back a cosmic curtain to reveal just how immense, intricate, and boundless the universe truly is. Its ability to detect faint light from galaxies that formed billions of years ago has transformed a sense of distant possibility into a vivid reality that can now be studied in detail. With a single image, humanity was confronted with a truth that has always lingered in theory, but rarely in such undeniable clarity. The universe is far vaster and more populated with structure and energy than most dared to imagine. Before we start, smash the like and subscribe buttons for more updates. The telescope's design, optimized for infrared observation, has given astronomers a new tool for peeling back the layers of time itself. Unlike earlier telescopes that were limited by visible light, Webb can capture radiation that has traveled through billions of years of expansion and distortion. That capability turns it into a time machine. Not metaphorically, but physically, because the light arriving at its mirrors today was emitted when the cosmos was still young. What once were smudges and faint suggestions in Hubble images have now been revealed as sprawling, fully formed galaxies with distinct structures. Entire clusters emerge where only hints once lingered, showing not only that the universe is teeming with galaxies, but also that it was already rich and active far earlier than once thought. The true scale that Webb reveals is not measured simply in distance, but in abundance. Where astronomers expected to find a handful of galaxies, the telescope consistently unveils hundreds, sometimes thousands, filling the frame. Each of these galaxies contains billions of stars, each star with the potential of planetary systems. The multiplicative effect of this realization changes how humanity perceives its own place in the cosmic story. The universe is not just large, it is dense with creation. The structures stretch outward not as scattered points in the void, but as great webs of matter connected across unfathomable gulfs, shaping the architecture of the cosmos in a way that demands entirely new perspectives. One of the most staggering implications of Webb's observations is how they compress humanity's sense of cosmic time. Looking billions of years into the past, the telescope reveals galaxies forming when the universe was a mere fraction of its current age. This reshapes theories of how quickly matter coalesced into stars, how galaxies matured, and how the first supermassive black holes appeared so early. What scientists once assumed would take far longer spans of time seems to have unfolded at a rapid pace. The scale of time, once thought to be somewhat orderly and gradual, is now recognized as explosive and dynamic, pushing astrophysical models toward more radical explanations. The telescope also extends human reach beyond the purely physical by capturing the invisible. Dust clouds that once obscured star nurseries are penetrated by its infrared vision, unveiling vast regions where new suns are born. These cosmic nurseries, previously cloaked in mystery, now stand as reminders of the universe's constant renewal. By observing the scale of these formations, Webb makes clear that the cycle of creation is not a relic of the past, but an ongoing phenomenon. The grand scale of the universe is not frozen, but alive, with stars igniting, planets forming, and galaxies interacting in colossal dances of gravity. When astronomers point Webb toward clusters of galaxies, another layer of scale becomes visible through gravitational lensing. The immense gravity of galaxy clusters bends the light from even more distant galaxies behind them, creating magnified images of objects that would otherwise remain hidden. This phenomenon turns natural cosmic structures into amplifiers, allowing Webb to see further than ever before. Each lensed image adds yet another layer of depth, showing that for every galaxy we can see directly, countless others lie still further back. The scale stretches on with no apparent limit, a reminder that each discovery is only the beginning of another horizon. The recognition of such immensity forces reflection not only on scientific questions but on philosophical ones as well. To grasp that what appears as a small field of view is in fact a window crowded with thousands of galaxies challenges the very idea of human centrality. The scale of the universe revealed by Webb suggests that life, while precious on Earth, may not be rare in the cosmos. With billions of galaxies, each hosting billions of stars and untold numbers of planets, the probabilities lean toward abundance rather than isolation. The telescope doesn't just reveal light, it ignites wonder about the possibilities that may lie on worlds orbiting distant suns, worlds that may have their own stories of emergence, struggle, and discovery. The detail Webb provides also sharpens understanding of cosmic structure. Rather than a random scattering, the universe appears woven into a vast web, with filaments of dark matter and galaxies stretching across incomprehensible distances. These structures are the scaffolding of creation, showing how matter organizes itself under the influence of gravity. The sheer size of these cosmic webs redefines large scale from any human perspective. What once seemed like separate clusters are revealed as parts of interconnected superstructures spanning hundreds of millions of light years. This layering of scales, from the birth of stars to the sweep of galactic filaments, demonstrates the unity of processes across magnitudes that dwarf imagination. The technology that enables these revelations is itself a testament to human ambition. Webb's segmented golden mirror, its shield protecting against the heat of the sun, and its instruments cooled to detect faint signals all serve a singular purpose: to stretch vision further. Its success is not just in engineering, but in the way it has opened perception to truths that were always there yet unseen. The scale of the universe was not created by the telescope, it was always present. But now, for the first time, it is visible in its true richness. That act of unveiling shifts not only scientific knowledge, but collective imagination. Every new image sparks recalibration of what is considered possible. Tiny arcs of light at the edges of fields may represent galaxies from the earliest epochs, pushing the boundary of how close we can peer to the dawn of time. Each such detection stretches the known universe backward, closer to its origins. The scale expands not only outward into space, but backward into time, layering epochs of cosmic history into a narrative that is only now being assembled. Humanity is in effect watching the story of the universe unfold in reverse, uncovering chapters that were written billions of years before Earth itself existed. The implications of such discoveries ripple into other scientific fields. Cosmology gains sharper constraints for theories of inflation and expansion. Particle physics finds new data points in the behavior of matter under extreme conditions. Even planetary science benefits, as Webb's ability to analyze atmospheres of exoplanets ties the vastness of galaxies to the intimate scale of possible habitable worlds. The scale of the universe is therefore not a remote curiosity, but a direct context for understanding the place of life within it. Yet beyond the numbers, beyond the red shifts and data charts, lies the simple experience of awe. To look upon an image where every point of light is not a star but an entire galaxy redefines wonder. The telescope does not diminish the night sky into cold measurements, it amplifies its grandeur. The scale revealed is one that stretches imagination to its limits, forcing recognition of a cosmos that is at once terrifyingly vast and breathtakingly beautiful. As Webb continues its mission, each new observation adds another layer to this unfolding scale. Galaxies colliding, stars forming, black holes feeding, all captured in detail that was once impossible, extend the boundaries of what it means to see. The telescope is not merely an instrument, but a bridge between human perception and the immensity of existence. Through it, the scale of the universe becomes not just an abstraction, but a visible, undeniable reality. What Webb has revealed is not an end, but a beginning. The true scale of the universe is now laid open in a way that demands both humility and exploration. Every faint glimmer, every arc of lensed light, every cluster bursting with billions of suns stands as an invitation to journey further into understanding. The telescope has shown that the cosmos is not just larger than thought. It is more intricate, more alive, and more filled with possibility than ever imagined. The human story, once confined to a small planet orbiting an ordinary star, is now unmistakably part of a universe so immense that its boundaries may never be reached. The James Webb Space Telescope did not merely extend the reach of astronomy, it redefined what the act of looking outward even means. With its launch, the practice of observation transformed from sketching rough outlines of a cosmic landscape into reading fine-grained details of a manuscript written in light. To add 2,500 words of new reflection is to unfold deeper layers of its significance, to follow the threads of implication across science, philosophy, technology, and imagination without stepping again on what has already been traced. The telescope's revelations underscore the layered nature of cosmic understanding. Before Webb, much of astrophysics involved inferring truths from indirect evidence, measuring redshifts, studying gravitational perturbations, and running simulations. Those methods remain indispensable, but Webb provides direct confirmations that anchor speculation in tangible reality. Its sensitivity and precision give astronomers confidence to refine long-standing theories. Where models once suggested that galaxies might have emerged earlier than expected, Webb's images confirm it. Where textbooks predicted dusty star nurseries hidden beyond visible wavelengths, Webb reveals them in luminous detail. This bridging between prediction and confirmation elevates astronomy from theory into witnessed reality, showing the discipline to be both an imaginative art and a direct science of seeing. The telescope also pushes forward the art of calibration. Instruments designed to capture photons billions of years old require unprecedented stability and sensitivity. Engineers tuned Webb to remain still in the vast quiet of space, avoiding vibrations that would blur its vision. Every observation is the product of precision, of countless hours of adjustments that keep its mirrors aligned at tolerances smaller than the width of a human hair. That level of control echoes through the images it delivers, reminding us that the scale of the universe is revealed only when human craftsmanship can meet cosmic silence with exactitude. It is as though a symphony of technology and physics was required simply to tune in to the music of the cosmos. Beyond the raw data, Webb's findings highlight the layered scales of complexity that exist in the universe. Stars are not simply points of light, but factories of heavier elements. Galaxies are not merely groupings of stars, but dynamic systems that interact, merge, and evolve in complex gravitational choreographies. When Webb captures two galaxies colliding, it documents not just a spectacle, but a process that shapes star formation, triggers supernovae, and redistributes matter on scales that stretch for hundreds of thousands of light years. Each observation is a window into interconnected cycles, showing that scale is not only about size, but about the interplay of forces across time. The telescope's ability to peer into the atmospheres of exoplanets extends the discussion of scale down to intimate levels. By splitting light into spectra, Webb detects molecules and gases orbiting stars light years away. In doing so, it bridges the unimaginable scales of galaxies with the fragile conditions of planetary climates. The notion that water vapor or carbon dioxide can be identified on distant worlds reminds us that the universe's vastness contains echoes of the familiar. Scale, in this sense, shrinks from billions of light years to atmospheric thicknesses, yet the connection between the two is profound. The cosmos is at once incomprehensibly vast and intimately relatable. The unveiling of such scales influences human culture as deeply as it shapes science. Throughout history, revolutions in astronomy have altered humanity's conception of itself. Copernicus displaced Earth from the center. Galileo revealed the moons of Jupiter. Hubble uncovered galaxies beyond the Milky Way. Webb continues this trajectory, each image another nudge outward, another reminder that centrality is an illusion. The telescope's revelations enter art, literature, philosophy, and religion, reshaping how societies imagine their place. A galaxy rendered in Webb's golden hues is more than data. It is a symbol, a shared vision that transcends borders and languages, pulling all of humanity into a collective gaze. The challenge of comprehending scale is not only external, but internal. When faced with images showing thousands of galaxies in a patch of sky no larger than a grain of sand held at arm's length, the human mind strains to integrate the numbers. Such comprehension demands more than logic. It requires imagination. To truly feel the immensity, one must allow the mind to stretch, to abandon familiar measures, and to dwell in expanses that resist analogy. Webb's images demand new forms of storytelling, metaphors, and languages that can convey dimensions beyond human intuition. In doing so, the telescope does not just expand science, it expands imagination itself. Webb's observations also point toward the inevitability of future discovery. Each image raises questions as quickly as it answers them. Why did massive black holes form so early in cosmic history? How did galaxies achieve maturity so soon after the Big Bang? What mechanisms drive the alignment of galaxies into vast filaments? These mysteries are not failures, but invitations, demonstrating that the true scale of the universe is not static, but ever deepening. Webb does not reveal a final picture, it reveals a doorway. Every photon it captures is both an answer and a beckoning toward more profound exploration. The scale of energy released across the cosmos also becomes more tangible through Webb's eyes. Supernovae blaze with brilliance equal to entire galaxies for brief moments, while quasars radiate with ferocity powered by black holes millions of times the mass of the Sun. These extremes emphasize that the universe's scale is not only about distance, but about intensity. The cosmos contains energies that dwarf comprehension, explosions that outshine the cumulative light of billions of stars. Webb's sensitivity makes these events visible in new clarity, reminding us that the fabric of reality is woven with threads of both delicate creation and violent transformation. Another layer emerges when considering time not as a simple sequence, but as a vast ocean in which Webb floats. Each captured photon has journeyed across billions of years, untouched until it strikes the telescope's detectors. This act transforms ancient light into present knowledge. The telescope collapses vast epochs into moments of observation, allowing humanity to hold in its hands signals that began their voyage before Earth had formed. That communion across time underscores the fact that scale is not only spatial, but temporal. The telescope links the now with the primordial, weaving continuity between human experience and cosmic history. The collaborative nature of the telescope itself mirrors the scale of the universe it explores. No single nation could have built it alone. Its creation required cooperation between agencies, scientists, and engineers across continents. That global effort echoes the universality of the cosmos. Just as no galaxy exists in isolation, but interacts within clusters and webs, so too does human discovery emerge from collective endeavor. The scale of the universe, as revealed by Webb, demands a scale of human collaboration that transcends boundaries, reminding us that curiosity is a shared inheritance. Perhaps one of the most striking aspects of Webb's revelations is the way they recalibrate humility. For centuries, humanity has struggled between feelings of central importance and recognition of cosmic insignificance. Webb intensifies the latter while deepening the former in unexpected ways. On one hand, the sheer number of galaxies and stars dwarfs human existence. On the other, the ability to build a machine that perceives them connects humanity to the cosmos in a profound way. The telescope affirms that even a small species on a tiny planet can reach across time and space to witness the immensity of creation. In this paradox lies a new form of dignity, not centrality, but participation in the grand narrative of existence. The scale of structures observed by Webb also forces reconsideration of cosmic destiny. Galaxies are not static. They merge, evolve, and sometimes consume one another. The telescope reveals the inevitability of such interactions, showing snapshots of galaxies in the midst of collision. These events, which unfold over millions of years, demonstrate that the universe is not a fixed stage, but a dynamic drama. The Milky Way itself will one day merge with Andromeda, reshaping both into a new form. Webb allows humanity to preview such fates, to glimpse in other galaxies what will eventually be our own story written large. Webb's success also underscores the role of patience in revealing scale. Decades of planning, billions of dollars of investment, years of testing, all for the purpose of aligning a telescope at a remote location a million miles from Earth. The payoff is not instant, but cumulative. Each image is the product of years of unseen labor, each spectrum the fruit of meticulous calibration. This reminds us that to comprehend scale, one must adopt long horizons, to think not in days or years but in decades and centuries. The telescope itself is an emblem of long vision, a reminder that great scales demand great patience. Even the aesthetic qualities of Webb's images contribute to the perception of scale. The golden tones, the arcs of lensed galaxies, the intricate structures of nebulae, these are not just scientific data, but artistic experiences. They engage the senses, evoking awe that transcends technical description. In doing so, they reach wider audiences, drawing people into a recognition of the cosmos who might never read an astrophysics paper. The aesthetic dimension ensures that the scale of the universe is not locked away in laboratories, but shared across cultures, embedding itself in the collective imagination. Webb also invites reconsideration of time from another angle: the future. If the telescope can reveal the distant past, it also hints at what lies ahead for humanity. By detecting exoplanetary atmospheres, it prepares the ground for the possibility of finding biosignatures. By mapping galaxy formation, it sharpens understanding of cosmic evolution, which may one day influence how civilizations navigate interstellar existence. In this sense, the telescope is not only a window backward, but a bridge forward. It demonstrates that to comprehend the universe's scale is to begin preparing for a future in which humanity may extend beyond its home world. The cultural impact of Webb will also endure. Just as Hubble's images became iconic, shaping public perception of the cosmos for a generation, Webb's visions will define the next era. They will appear in classrooms, museums, documentaries, and digital spaces, serving as the visual language of the universe for decades. The scale of their influence extends far beyond academia, seeding wonder in children, sparking creativity in artists, and fueling inquiry in philosophers. The telescope becomes not just a scientific tool, but a cultural artifact, a touchstone of human curiosity. The revelations of the James Webb Space Telescope do more than enlarge the boundaries of astronomy. They create entirely new domains of inquiry. Each image, each spectral line, each unexpected feature is not just an addition to human knowledge, but a transformation of the very questions science dares to ask. To continue expanding upon its implications without repetition requires following the ripples outward, to technology, to philosophy, to the cultural psyche, and to futures that Webb itself is only beginning to make imaginable. One of the most striking implications of Webb's discoveries lies in its relationship with uncertainty. In earlier eras of astronomy, telescopes often reduced uncertainty, providing clarity where only speculation existed. Webb, however, functions in dual roles. It confirms some long-standing theories, but simultaneously multiplies unknowns. When astronomers observe galaxies forming sooner than expected, it does not settle the debate about cosmic history. It opens new puzzles. Why did star formation accelerate so rapidly? What role did dark matter play in shaping these early structures? The telescope reveals truths, but also magnifies the mysteries, demonstrating that the true scale of the universe is defined as much by questions as by answers. The telescope's revelations also highlight the role of invisible structures that underpin reality. Dark matter and dark energy remain unseen forces, yet their influence is indirectly visible in Webb's images. The arcs of gravitational lensing, the distribution of galaxies, and the motion of cosmic filaments all point toward underlying frameworks of matter and energy that human senses cannot perceive. Webb's capacity to make their effects visible reminds us that scale is not only about what can be seen, but also about the unseen scaffolding of existence. The telescope thus becomes a paradoxical tool. It reveals the invisible, making the intangible a part of human understanding. The scale of Webb's accomplishment also lies in the realm of engineering. Consider the act of placing such a delicate instrument at the L2 Lagrange point, 1,000,000 miles from Earth, where gravitational forces and orbital mechanics balance just enough to hold the telescope steady. That placement is not incidental. It is essential to minimize thermal interference and maximize observational stability. By sending the telescope so far into space, humanity has created a vantage point that transcends the limitations of Earth-based observation. This feat reflects a mastery of celestial mechanics, orbital design, and remote operations, each itself a triumph that amplifies the sense of cosmic scale. Webb's data handling capacity is another hidden marvel. Every photon collected becomes part of a torrent of information transmitted back to Earth, processed, calibrated, and analyzed by teams around the globe. The pipeline from distant light to scientific conclusion is itself a microcosm of scale, spanning from ancient galaxies to contemporary computer systems. The ability to coordinate such flows of data reveals that the scale of discovery depends as much on information technology as on mirrors and detectors. The telescope stands as a reminder that human progress is intertwined with the capacity to capture, store, and interpret the faintest whispers of the cosmos. The telescope's contribution to planetary science is equally profound. When Webb turns its gaze toward exoplanets, It applies its spectral sensitivity to reveal atmospheric composition. This extends astronomy beyond the study of stars and galaxies into the realm of environments, climates, and potential habitability. The scale of implication here is intimate yet vast. Intimate because it concerns conditions for life, vast because it multiplies the possible worlds where such conditions exist. For the first time in history, humanity is not merely guessing at exoplanetary atmospheres, it is detecting them. The line between speculation and evidence has been crossed, and that changes how the search for life is approached. The cultural impact of Webb also cannot be overstated. In earlier centuries, star charts and planetary models shaped navigation, trade, and religious thought. Today, Webb's images shape global imagination. They appear on screens in classrooms, circulate through media, and anchor documentaries that inspire millions. These images are not private to scientists. They are shared across cultures, becoming part of a collective inheritance. The telescope thus acts as a democratizing force, opening the grandeur of the universe to anyone with access to a screen. Its revelations belong not just to institutions, but to humanity at large, expanding awareness across borders. The telescope's revelations also shift perspectives on permanence. When Webb captures galaxies colliding or stars forming, it demonstrates that nothing in the cosmos is static. Even the largest structures undergo transformation. This truth mirrors human experience at a new scale. Civilizations rise and fall, continents shift, climates change, and lives unfold in cycles of creation and destruction. Webb extends this pattern into the universal, showing that impermanence is a fundamental property of existence itself. The cosmos is dynamic, not fixed, and this dynamism is a source of both beauty and humility. The ethical dimensions of Webb's discoveries are another layer worth exploring. As humanity peers into atmospheres of exoplanets and identifies worlds that may resemble Earth, questions emerge. What responsibilities arise if life is discovered elsewhere? How should humanity approach the idea of other intelligences if they exist? Even if no contact is ever made, the knowledge that life may not be unique changes how humans perceive their stewardship of Earth. The telescope thus indirectly influences ethical frameworks, pressing humanity to consider its role within a larger cosmic ecosystem. Webb also extends the scale of narrative. Human history is often told in epochs, ancient, medieval, modern, but Webb's images push narrative into billions of years. The telescope forces recognition that human time is a thin slice in a continuum that stretches nearly 14 billion years backward. This recognition alters the way history itself is conceptualized. Civilizations, empires, and lifespans shrink in the light of galactic time. Yet rather than diminishing human importance, this expansion situates humanity within a vast, unfolding story. Each generation contributes a verse to a cosmic epic that began long before and will continue long after. The telescope also demonstrates the resilience of human aspiration. Its construction was plagued with delays, budget overruns, and doubts. Many questioned whether it would ever fly, let alone function. Yet its success proves that perseverance across decades can yield unprecedented achievements. This resilience mirrors cosmic persistence, where stars form in defiance of entropy. Galaxies evolve despite chaos, and life emerges against improbable odds. Webb thus embodies a parallel between human determination and cosmic endurance, showing that both matter and mind push forward despite obstacles. Another dimension of scale emerges in Webb's role as a precursor. While its discoveries are groundbreaking, they also lay foundations for telescopes yet to come. Future observatories will be designed with knowledge gained from Webb, pushing even further into the early universe, or zeroing in on exoplanet biosignatures. In this sense, Webb is not an endpoint but a bridge. It occupies a moment in technological progression, its revelations both final in their grandeur and initial in their implications. The scale of discovery is therefore temporal, not just in looking backward, but in projecting forward into what humanity might achieve. The telescope also reshapes perception of silence. In space, sound does not travel, yet the images Webb produces convey a kind of visual resonance. They remind us that silence is not emptiness. The vacuum of space hums with light, gravity, and energy, all of which carry stories across billions of years. Webb captures these silent signals, converting them into images and spectra that speak across cultures. In this way, the telescope gives voice to the voiceless expanse. transforming cosmic silence into human knowledge. The concept of boundaries also shifts under Webb's revelations. Where once astronomers thought they had reached the edge of observable galaxies, Webb reveals yet more layers. The horizon of vision recedes continually, suggesting that there may never be a final boundary, only expanding vistas. This challenges human instinct for closure. The universe, as seen through Webb, refuses to be neatly contained. It resists finality, insisting on boundlessness. The scale of the universe, then, is not only vast, but infinite in its capacity to exceed expectations. On a psychological level, Webb's discoveries influence how individuals perceive themselves. To confront such immensity can evoke feelings of insignificance, but it can also produce empowerment. If tiny photons can travel billions of years to be captured by a telescope built by human hands, then human actions, though small, matter in profound ways. The telescope demonstrates that scale is not a barrier to meaning. Even within vastness, there is connection. The photons Webb captures are tangible links between human experience and cosmic history, binding the smallest with the largest. The telescope's impact also reaches into education. For students encountering astronomy for the first time, Webb's images provide more than facts. They provide inspiration. They ignite curiosity, prompting questions that extend beyond textbooks. What was the universe like before galaxies? How do stars form? Could there be life beyond Earth? By sparking these questions, Webb ensures that new generations will carry forward the quest for knowledge. Its scale of influence extends not only across space, but across time, shaping minds for decades to come. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on James Webb's discovery changing our view of space? We want to hear from you. Thank you for watching and see you next time.